Hello everyone, and welcome back to our fourth video and final video for lesson number 9. And again, lesson number 9, we've seen the other 3 videos, we're analyzing derivative graphs. So this video is going to be very short. What I want to just do is I want to just do one more example that I pulled from my AB classes about just kind of solidifying, looking at a graph of f. Let's just kind of see this kind of question, arrange the expressions from the largest to smallest, and then like I said before in the previous videos, I'm going to do a nice little summary for us. So it says the graph is twice differentiable function f is shown to the figure to the right. So this is f of x. So again, what you see is what you get. So a very easy example. And then it says we want to arrange these expressions from largest to smallest. So f of negative 2, well, that's going to be 0. All right, so we're in Algebra 1 class right now. And f of 2 is also going to be 0. So we know that Roman number 1 is going to be 0. So kind of boring, but it is what it is. We like it. For the next one, f prime of negative 2, well, this is going to talk about where f of x is increasing and decreasing, right? Increasing, decreasing. So f prime of negative 2 is going to be positive, right? I don't know what exactly it is, but I know it's going to be positive. This number is going to be positive because f prime of 2, the slope of f of x, is positive, all right? But again, in calculus, we don't say the slope of f of x, we say f prime of x is positive. So we know that f prime of x is greater than 0. That's the justification we're going to do with that. F prime of 2, same thing, same different story. We're going to do that. So it's going to be plus another positive. So I know this is going to be equal to a positive number. So, I wonder what the next one's going to be, right? So we have 0 for 1, we have a positive number for 2. So we automatically know that 2 must be greater than 1, right? 2 must be greater than 1. So we can eliminate A and B because it's asking us to go from the largest to the smallest, right? And so let's look at the next example here, and this is going to be Roman numeral 3. And let's look at that one. So now f double prime of 2, well, you guessed it, this is going to be concavity, right? This is going to be concavity. And so f double prime of negative 2. Well, this is looking to be part of this graph right here. And this is a negative, right? We're sad. It's concave down. So this is going to be concave down, right? Which means that our second derivative here is actually going to be less than 0. So it's going to be concave down. We have a negative minus, and now let's look into what's going on with f double prime of 2. Well, f double prime of 2 is part of this function, which is smiling, we're concave up, which is going to be a positive number. So a negative minus a positive is always a negative because this then becomes, it's like a negative plus a negative, right? So this is always going to be a negative value. So I know that 2 is first, I know that 1 is second, and then I know that third is last. I don't know why I'm doing this. This is meant to be 2, and this is meant to be 3. So what is the answer? So the answer here is going to be equal to D. Okay, to D. Let's summarize. Let's summarize what we just did in all 4 of these videos. So let's do it. Summary time. All right. So let's do a summary of everything that we need to know, okay? So when f of x is increasing, okay, that means that f prime of x is greater than 0. When f of x is decreasing, that means f prime of x is less than 0. When f prime of x is concave up, I can say several things. I can say that the second derivative is greater than 0 and f prime of x is increasing. When f of x is concave down, I can say that the second derivative is less than 0 or f prime of x is decreasing. Okay, so now that's the idea between that. Let's continue on with more stuff. I can say that f of x has a relative maximum when f prime of x changes signs from positive to negative, and I can say that f prime of x has a relative minimum when f prime of x changes signs from negative to positive. And then finally, our final one is I can say that f of x has a point of inflection, right, where f prime of x, well, f double prime of x changes signs, and where f prime of x has, so I know I'm writing vertical tangent here, but I meant horizontal tangent. Okay? Which means that it's basically a max or min of f prime of x. All right, so there's all the crazy written stuff. So if you got it in you, I'm going to show you one more graph, and we're going to find out all of these things. It's going to be a very, very, very basic graph to go and figure out all 7 of these things, and then we're going to call it a day. Okay, so let's start with these 4 things right here. So where is f of x increasing? So f of x is increasing on the interval from 0 to 2. And the justification you're going to always write for this is that f prime of x is greater than 0. Okay? Where is f of x decreasing? That's going to be from 2 to 3. And it's going to be because f prime of x is less than 0. Where do we have a relative maximum? Well, a relative maximum is going to be at x is equal to 2, because f prime of x changes signs from positive to negative. Where does f of x have a relative minimum? I'm going to just really quickly continue on with my graph right there, because I need to actually do that. So it has a relative minimum at x equals 3, because f prime of x changes signs from negative to positive. And again, I want to just say, for all of these questions, when you're looking at f prime of x, you're looking at what's happening with the y values of f prime of x. Where is it above the x-axis? Where is it below the x-axis? Where is it changing signs? Right? That's what you're going to do for that. So that's going to be the first part. And then finally, as I just said, where is it concave up and concave down? Well, it is going to be concave up from 0 to 1. And it's going to be concave up from, let's just say this is 2.5 to 3. And it's because f prime of x is increasing, or the second derivative, which is the slope of this slope, is going to be greater than 0. Where am I concave down? I'm going to be concave down from 1 to 2.5. And again, it's because f prime of x is decreasing, or the second derivative is less than 0. And then finally, where are my points of inflection? My points of inflection are at x equals 1 and x equals 2.5. And the reason why is because my second derivative is changing signs. Okay? So there you go, ladies and gentlemen. There's a lot of stuff. So, and for these 3 examples, you're looking at slope. So these are slope right here. And this guy right here, this one is going to be horizontal tangents. Horizontal tangent. And I just realized that over here, I said vertical tangent. So I meant to say horizontal tangent. So hopefully you guys are like, oops, yeah, horizontal tangent. Horizontal tangent. So I'm glad I did that example. So yeah, so hopefully that wasn't freaking you guys out. All right, so that is it. That is my summary and my lesson on number 9. So, Mighty number 9, we're good to go. And that is, for my BC students, that is the end of Unit 1. So, congratulations. We will see you guys back in the next video.